This video will show you how to do a continuous by continuous interaction. In this case, my outcome variable is total engagement. My incoming variables are total reprimands and total praise, and those are both continuous. And I have an additional male student control. So I need to create my interaction term. So interaction between praise and reprimands. Let's find my two continuous variables. Run my code. So I have my interaction term now. Put in my dependent variable, both parent variables, my control, male student, and then in the next block, the interaction term. Here's my output. And as we can see here, that in this model, the interaction term between praise and reprimands is not statistically significant. And the R squared does not go up very much by adding the interaction term in, so the R squared is 0.001. Nevertheless, let's pretend that the interaction term was significant for demonstration purposes. So right-click, export, Excel. Make sure you find a place to put it. It's going to be praise, reprimand, interaction. Can't paste it, so I just have to click OK and open the containing folder. It exports. Here's my model. I'm going to write down my model again like I've always done. Y equals beta naught plus beta 1 times reprimands plus beta 2 times praise plus beta 3 times gender or male plus beta 4 times the interaction between praise and reprimands. Okay, because male is a dummy variable, I'm going to define my interaction for females, and so that term will disappear. So my new equation is beta naught plus beta 1 times reprimands plus beta 2 times praise plus beta 4 times praise times reprimands. In order to make my 4x4 table, I need to find out what one standard deviation below the mean is and what standard deviation above the mean is. So we're going to do -1 standard deviation of praise. Doesn't like my code, so 1 standard deviation below the mean praise, 1 standard deviation above the mean praise. We can always alter that if that's too wordy. 1 standard deviation below mean reprimands, 1 standard deviation above the mean reprimands. And I just have to figure out what those are from the data file. So let's go back here and go to Analyze, Descriptive Statistics, Frequencies, find praise and reprimands. Request the standard deviation. Turn off Display Frequency Table. Click OK. So the standard deviation is 1.59 and 0.94 for reprimands and praise, respectively. These are centered at 0. go back to my Excel and capture that information. So it's going to be, so this one here is going to be, this is for praise, so negative 0.93811, and this is going to be positive 0.93811, because again the mean is 0. And here it's going to be negative 1.59266, and then positive 1.59266. Now we just have to do the equation work. Make this a little bigger. I should move it over so I can see it easier. So it's going to be equal to the intercept, beta naught, which is the constant, plus beta 1. Oh, and I forgot my dollar sign. I want to make sure that these things are always fixed, times the value for, the first one is reprimands, so that's the value over here. So I want to keep the column constant, but not the row, so I want to put a dollar sign in front of the column, which is H, plus beta 2, which is praise. I want to keep that constant always, so dollar signs around both the row and the column, times the praise value. And for this one, I want to keep the row constant, but not the column, plus, then finally beta 4. I want to keep beta 4 always constant, times praise, same pattern as before, where the column is constant but not the row, times reprimand. So I did it backwards. I started with reprimands and then did praise, but because of the commutative property of multiplication, it still works. Times this, where I keep the row constant and allow the column to vary. Ta-da, I have my predicted value, and I drag down my formula. Should work. It looks like it did. Yeah. Now I just got to make the graph. So I insert line, insert line graph. Oh, it did all sorts of weird stuff. It selected things for me. Actually, it did a pretty good job. Huh, never knew we could do that. Well, I want to make sure it does a better job than it's done. So select data. I'm going to eliminate everything. There, I think we're okay now. Now I'll select the data range. If it'll allow me, get it canceled. It's really being finicky. Let's move this up. Select data. Get rid of that. Now I can move it for whatever reason. Chart data range is going to be this. Series 1. Actually, let's make it this whole thing, so we'll do the one, capture the labels as well. Did it work? It looks like it did. Praise. Okay, now let's just need to clean it up. So this is really, Excel's really not liking me. Let's do legend. And as we can see, we have two parallel lines, which is exactly what the non-significant interaction tells us. The slope between these things does not vary very much. Add some axis titles. So this is going to be the value of praise, and this X title is going to be total engagement. So this is an ordinal interaction that's not even statistically significant. So the interaction between praise and reprimands for female students, because remember I called the male value 0 for females to have that term vanish. And so here's my interaction plot. Now I might want to do a better job, as I mentioned before, to labeling these things. And also this is a fun thing with Excel, because I have negative values, it will actually put the x-axis values in the middle of the graph, which is pretty. And so I could play around with that to somehow bring those down. But you get the general idea. This is how you graph a continuous by continuous interaction. It does not matter which one you decide to be on the x-axis versus the legend. In this case, I chose to put praise on the x-axis and have reprimands in the legend. You would still see the same story if we reverse them. It just depends on how you want to sell it.